This video is all about solving quadratic equations. I can solve quadratic equations using very different methods. You can use factoring, grouping, completing the square. You can use the square root method, and you can also use the quadratic formula. That's only a few of the things that you can use to solve quadratic equations. So I'm going to start off with factoring because you probably remember that one. Some of your teachers taught you different than I'm about to do this, and if you know that method by heart and you like that method, you're more than welcome to do it. I'm going to use the first example has a 1 in front of the x squared. So anytime there's a 1 in front of the x squared, it's a little bit easier. So my first example is x squared plus x minus 6 equals 0. Before we can solve, we need to make sure everything is on the left side. So it looks like this standard form equation, ax squared plus bx plus c equals 0. Now, I like to do a t-chart and list all the values that will give me this negative 6. So I'm looking for something to multiply to negative 6. So that is 1 and 6 and 2 and 3. Now, yes, I know that this isn't going to make a negative 6, but it will. Just a minute. They need to subtract, because this is a negative sign, to give us the middle number. So we're looking for two numbers that subtract to give us, one second. There we go. A positive 1. So I want to add or subtract right here in this spot to give us positive 1. Now, the middle number also tells us the sign of the larger factor. So I know that the larger number in my factors here needs to be positive, which means my negative is here. Now, negative 1 times 6 is negative 6, and negative 2 times 3 is negative 6. But which one, when I subtract them, gives me 1? Well, that's 5, and that's 1. So I'm going to use the factors of negative 2 and 3. The next step is to put them in factored form. Factored form means that you split this x, so x, x, and then each one of our multipliers go inside here, negative 2, positive 3. Okay, now we can use the zero factor theorem to say, well, that means x minus 2 equals 0 and x plus 3 equals 0. So I've split each one of these factors, gets set equal to 0. When you solve this, we get x equals 2 and x equals negative 3. So you write your answer in set notation, smallest to largest, and there you go. Now some of you are going to say, well, can I just skip from here to here? Yes, if you see that pattern, this number always changes sign, so it became a positive 2 and a negative 3. But some people don't see that pattern and they need this work shown. Either way, it's fine for me. Just remember you're changing your sign. So that, remember, that's the difference between factored form and solutions. They change signs. And we'll see that more in the next video. We're going to graph these and we're going to look at all of their key features. Okay, if you want to try another problem, you can try x squared minus 3x plus 2 equals 0. I'm going to do this one a little bit quicker. So pause me, work it out, see if you can get it before I do. Okay, so I'm multiplying to 2 right here, and I want to add, because this is a plus sign, to negative 3. So how can I get that? Well, the only multipliers of 2 are 1 and 2 because it's prime. But how do I get it to add to negative 3? To be negative 3, we know that that means our bigger factor needs to be negative. But 1 times negative 2 gives me negative 2. So I have to also change the sign of the 1, because now a negative times a negative gives me that positive, and negative 1 plus negative 2 is negative 3. Okay, so my factors are x minus 1, x minus 2 equals 0. When I solve both of those, I get x minus 1 equals 0, x minus 2 equals 0, so x equals 1 and x equals 2. We can have at most 2 solutions. So you can have no solution, 1 solution, or 2 solutions. And in both of these, we got 2 solutions. And that happens because the squared on the quadratic formula, or the quadratic equation, tells us how many solutions that we can have. So we can have at most 2. Okay, let's look at another problem like this where we're going to use this method, and I'm going to solve this one 2 different ways. Sometimes we have a number, a coefficient, on the x squared. When that happens, you can do this different ways. Now, I know a lot of you had Ms. Selchek. If you had Ms. Selchek, she probably did the stacking method. So if you like that method, go ahead and use that method. I'm going to do what's called a slip and slide. I use 2 steps to help me remember how to manipulate this 4 right here. So the first step is a slip. I'm going to slip it back here to the end and multiply it times 9. So that's step 1. So when I rewrite this, I get x squared plus 15x plus 36 equals 0. So I manipulated it a little bit for a little while. I'll fix it in the next 2 steps. So this work is just like the work that I did from above. I'm going to make my little T-chart. I want it to multiply to give me 36. So that would be 1 times 36, 2 times 18, 3 times 12, 4 times 9, that's what we just used, and 6 times 6. Now, can you skip this step? Yes. If you know your multiplication, you can skip this step. Just be careful, because sometimes the factors that you think will work don't actually work. So check them and make sure they work. Okay, we're going to add the numbers together, and our bigger number is going to be positive, and we want 15. So when I add these together, that gives me 37. This one is 20. Here is 15. This one is 13, and this one is 12. So the numbers that work in this problem are 3 and 12. When I set up my factors, that gives me x plus 3, x plus 12 equals 0. Okay, here comes step 2, slide. Now that I've factored this problem, I have to undo this multiplication. And I do that by sliding that number that I used to multiply back into my problem. And I can just multiply or divide the factors right here by that multiplier. So I'm dividing both factors by 4. Now, that's going to leave a fraction answer for this guy, because 3/4 is 0.75. It doesn't give you a whole number. So the answer for this one is x equals negative 3/4. You see how I just jumped straight to the answer by changing my sign? And the answer for this factor, 12 divided by 4, gives you a whole number of 3, and it's positive 3. So my answer is negative 3. Okay, so those are your 2 answers, negative 3/4 and negative 3. Okay, I'm going to use another method this time called factor by grouping. You can split the middle term instead of moving that and using the slip and slide. So let me show you how to do that. In this example, I have 4x squared minus 12x plus 9 equals 0. So I'm going to split this 12. And the easiest factor for me is 6 plus 6 is 12. So I'm going to split that as a negative 6x minus 6x plus 9 equals 0. So this 12 became negative 6 minus 6. Now that I have them split, I can group them in pairs of 2. So the first 2 get grouped together, and the second 2 terms get grouped together. The next step is to look for GCF. Sorry, I just thought maybe I should write those steps for you. So in this one, we split the middle term. And in this one, we're looking for a GCF, greatest common factor. So that means, what do they have the same? What's in common between the 2 terms? Well, they're both divisible by 2, so I can take a 2 out of the parentheses. And they both have an x in their terms. So this 2x is getting factored out of this parentheses. So 2 times 2 will give me the 4 back, and x times x will give me back x squared. Okay, if I do negative 6 divided by 2, that's negative 3, and I took the x outside, so it's no longer inside the parentheses. For this next parentheses, I'm going to do the same thing. If it's leading with a negative, we want to pull that negative out of the parentheses. It's going to be a common factor. Also, 3 goes into 6 and 9. And this time I can't pull out an x because only the 6 has an x and the 9 is missing that. So I can only pull out a greatest common factor of negative 3. Okay, now I'm going to reverse this to figure out what numbers are left. So negative 6 divided by negative 3 is 2, and then the x is staying. And then positive 9 divided by negative 3 is negative 3. Now, you'll notice that my 2 leftover parentheses match. That should always happen. If it didn't happen, you did something incorrectly. My last step here, well, almost my last step, is called regroup. I'm going to regroup the common factors together, 2x minus 3, and then write one of the factors that matched from my previous line. Now, this just happened to match. They do not always match here. This is just a fancy problem where they matched. And that's okay. This means I have one solution because they match. And to fix this, you know what? I'm going to show you the math actually. So we will set both of these equal to 0, but they give us the same answer, so I'm going to do just one. When I set them both equal to 0, I get 2x equals 3, and then dividing out by 2, x equals 3 over 2. So this is your one solution for this problem right here. Okay, whew, that was solving by factoring. You should be able to do 1 through 4 using one of those methods on homework 6. The next 4 problems in the homework stem from the square root method. I like the square root method. Now, some of you can make it more difficult than it's supposed to be by factoring or multiplying out. So just be very careful. When do we use the square root method? I'm going to use it when I have 2 terms. So x squared equals some number. That's 2 terms, one here, one here. I'm also going to use it anytime my problem starts off with a parentheses. So this parentheses here with a squared, I'm also going to use the square root method. Do not multiply out this squared and cause more work. It's not wrong, but it's a longer problem than I intended it to be. Let me show you some examples here. So let's say, oh, well, I'm going to make one up, so it might not work out perfectly. Let's go with x minus 3 squared equals, let's make it crazy, 12. This isn't going to be pretty, but it's going to be fine. Notice that I have parentheses and I have a squared. If you factor this out, you can get a quadratic equation and then move this over and then solve using factoring. That's a lot. We don't want to do that. Instead, we want to first take care of the squared. To take care of the squared, you square root both sides, just like we did with our complex numbers. So I'm going to square root this side and square root this side. But when you square root something, be careful, you need to do plus or minus the square root of that number. So this 12 is plus or minus square root of 12. And on this side, the square and the square root are inverse operations, so they eliminate themselves. Okay, so now I have x minus 3 equals plus or minus the square root of 12. I'm solving for x, so the next step is to add the 3 and move it to the other side. Now be careful when you do that. We're going to put that 3 right here in front of this plus or minus sign. So that gives me 3 plus or minus square root of 12. And then you can stop because that's your answer. Now, if I can find the square root of 12, let's say it was instead the square root of 16, I could say, okay, this is 3 plus or minus 4, and then 3 plus 4 is 7, and 3 minus 4 is negative 1. And you could get 2 answers from that. But if you have an answer with a square root, you could just leave it right where it is. There is a problem on your homework that has a bunch of stuff added to it. So let's say we have 2 times x minus 2 squared plus 4 equals, I don't know, 20. For this problem, I have to first isolate the x squared before I can use the square root method. So I subtract 4. And now I know that you want to come in here and you want to distribute this 2 and you want to multiply this out. Do not. We're trying to get it isolated. So instead, we'll divide by 2 so that it's eliminated with the identity property. And now this problem looks very similar to the beginning of my other problem. So I'm going to do the square root on both sides to give me x minus 2 equals plus or minus the square root of 8. And then add 2 to both sides. So x equals 2 plus or minus the square root of 8. And this is a fine answer. You could simplify it to give me 2 plus or minus 2 square roots of 2. But you don't have to. I'll accept this answer. One more type of problem like this that'll show up, and I think I've seen it on your homework multiple times. Don't make it harder than it is. Let's say we had this right here, just an x squared, no parentheses. Well, what I want to do here is move the 49. So x squared equals 49. And then find the square root. So x equals plus or minus the square root of 49. And then we can do that math right here because I know you know, that the square root of 49 is 7. And I hope I didn't just do a homework problem. I might have, but oh well. So that's how you use the square root method. Now you need the square root method to do the next method. Another way to solve equations, and this one you can use with any type of equation. Sorry. This one is called completing the square. For this one, you need the formula to complete the square, and that is, we're going to do that, completing the square, by adding b divided by 2 squared to both sides of the equation. And remember, again, in standard form, we're going to take off the number with the x, and that's going to be our b. We'll divide it by 2, then square it, and then add it to both sides of the equation to keep it balanced. If b happens to be negative, you can drop that negative, or you can keep it. Either way, whatever number we get here will always be adding to both sides because that squared fixes that for us. So let's take a look at some problems. x squared plus 4x plus 1 equals 0. Now, when you're completing the square, you don't have to do this, but I found that it is very helpful if you do this. Rewrite your problem by moving the 1 to the other side, or subtracting that 1 to the other side. And if you notice, I also left 2 blank spots in my equation. That's where I'm going to put my completed square. So I'm going to do some side work over here. I'm going to find the b for the problem. It happened to be 4. Divide it by 2 and square it. So 4 divided by 2 is 2, and 2 squared is 4. This will help me complete my square. I'm going to add 4 to both sides. The whole point of completing the square is to get a problem that looks like the problems that we solved using the square root method. To do that, I'm going to fix this a little bit. I'm going to write my problem as it looked in the last problems. So this x becomes 1x here because we're going to square it on the outside. Then you're going to take b and divide it by 2, and it takes this spot right here. Okay, and then we can totally ignore this 4. The only reason we added 4 was to make this possible. If you want to, actually, you know what? I'll do it real fast. I'll show you what we did. I'm going to do the box method to prove that this is correct. So x plus 2 squared is x plus 2 times x plus 2. When I FOIL this back out, that gives me x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. So this matches what I originally had. All I've done is condensed it to its perfect square form. Okay? You don't have to do this work. I just wanted to show you. Now on the other side, that's 3. 4 minus 1 is 3. Now we have a problem that we can solve using the square root method. So I'm going to find the square root of both sides, leaving me with x plus 2 equals plus or minus the square root of 3. Subtract 2 from both sides, and we have x equals negative 2 plus or minus the square root of 3. And then you're finished. Once you have x isolated, you're done. I'm going to do that again if you need it. If you don't, just skip past me and go look at how I use the quadratic formula. If you want to work it out, pause me and then see if we get the same answer. This problem is x squared minus 6x equals 5. It's already set up for the perfect square. So I'm just going to put my spaces here. That's where I'm going to add numbers. And the number that I'm going to add can be found by using the formula b over 2 squared. So that is negative 6 over 2 squared. Now, you could do this by dropping that negative, like I said earlier, because the squared will fix that. Because negative 3 squared is the same thing as 3 squared. So I divided by 2 to give me negative 3, squared it to give me 9. I'm going to add 9 to both sides of my equation. Okay, now this is perfect right here. I'm going to rewrite it as a perfect square by dividing this number in half. Keep its sign, so it's a negative 3. And then 9 plus 5 is 14. So this is my new problem. I'm going to use the square root method by squaring both sides. Square rooting both sides to give me plus or minus 14. Add 3 to both sides, and x equals 3 plus or minus the square root of 14. It's beautiful. Okay, you can use this method with any quadratic equation. And the last thing I want to do, and I'm just going to do this really quickly because you've probably had the quadratic formula ingrained into your soul. If not, you should work on that, Get it ingrained in there. You should know it by heart. I'm going to write the standard form equation again for you so you can see where I'm getting my numbers from. Ax squared plus bx plus c equals 0. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So we're going to find a, b, and c from our equation and plug it into all these spots, simplify, and get a solution. You could use this method, the quadratic formula, for any quadratic equation. Sometimes it might get a little bit gross. Sometimes it's going to be easy. So like this is an easier problem. I like to only use the quadratic formula when you have a prime equation. That means I can't factor this 1 right here because only 1 times 1 is 1. But I can pull out my numbers for the quadratic equation. So this 1 is a, b is 5, and c is 1. Notice that I didn't say a is x squared. A is 1. It's just the coefficient. Do not put any of your x's inside this problem. Okay, here we go. X equals negative 5. Negative b just means the opposite sign of b. So ours is positive, it's negative in the formula. Plus or minus the square root of b squared. I have another thing to tell you. If b is negative in the original problem, drop it. Or make sure you put a parentheses around it when you're using the calculator. Okay, minus 4 times a, which is 1, times c, which is 1. All divided by 2 times which is 1. Okay, now be careful when you're doing this inside here. Order of operations say that we need to do the multiplications first, and then you can subtract the difference. So this is negative 5 plus or minus. Okay, so 5 times 5 is 25, and 4 times 1 times 1 is 4. So 25 minus 4 is 21 over 2. If you can't simplify this, you can stop here. But if you can get a whole number from this square root, then continue to do the math. I would do negative 5 plus this number divided by 2, and negative 5 minus this number divided by 2. So if you can simplify it, simplify it. Okay, thanks for hanging out with me. If you have questions, let me know. I'll do graphing to solve in the next video.